Ladies and gentlemen, boys and girls, once again, FrazierNation.com. Welcome once again, 2.5 determinants and inverses of matrices. This is basically the last section of your unit. Your test will be coming soon. I do advise everyone to grab Quizlet, just kind of like a little app, or you can go to the website, get a little bit of help with your review. Anyway, going to the objective, students will be able to calculate determinants and inverses of matrices if they exist. The inverses do not always exist, okay? We'll get into that later, but for now, the if they exist part is important. You will see when they do and when they don't. I want you to remember, square matrices have the same numbers of rows and columns like a 2x2 and a 3x3 matrix. So here's an example of a 2x2 matrix. We have 2 rows and 2 columns. So this is a 2x2, 3x3, 4x4. Same thing. Scalar multiplication, you're going to multiply each element by the front number or the scalar. So if I have a matrix like this, and let's call this 4, this number right here is called your scalar. Okay, so you will multiply each of these elements by 4. So this is going to be really important later on in our lesson. Just 2 things I want you guys to remember. Let's go ahead and move on. The one thing that you do need to know is the identity matrix. This helps when we talk about inverse matrices. Okay. Inverse matrix importance. Okay. This is when you have the main diagonal. I like to call it the front diagonal because it's the front number. Here's the back number. So when the front main diagonal has 1s and everything else is 0s. Okay, so you have your 2 examples right here, and let's move on. When you're finding the determinant of a matrix, the 3x3, 4x4, 5x5, those are really kind of more complex. We're going to stick with the 2x2. When you find the 2x2, you're going to multiply the front diagonal, you're going to multiply the back diagonal, and then you're going to subtract the 2. So let's have an example. So if I have a 1, 2, 3, and 4, this is going to be called determinant of A. Okay, so let's call this matrix A, and the determinant of A is going to be the front. So 1 times 4 minus, and then we have the back diagonal, 2 times 3. So this is 4 minus 6. So the determinant of A is -2. Okay, that's going to be really important. Next card. Finding the inverse of a matrix. You have to check your work when you're doing this. One thing that's important is the inverse matrix has a little -1 right here. This is called the inverse matrix. Find the determinant of your matrix named A. If it's 0, you stop right here. Okay, so here's your matrix A, and you find your determinant of A. Okay, so if you'll see right here, this is from S1, step 1. This is S1. Okay, if when you multiply these numbers and subtract, if this is 0, then you're going to stop. Step 2, find the opposite matrix. It's called the adjacent. It's called something. There's a term that goes with it. For our purposes, we're going to be calling it the opposite matrix. So let's just call this op A. Okay, op A. You're going to take and flip your front diagonal. So instead of A and D, you have D and A. You're going to find the opposite numbers of the back diagonal. So instead of positive B, it's going to be negative B. You're just going to put negatives in front of these numbers. So this is your S2 right here. Step 3, scalar multiplication of step one's matrix. Okay, so you're going to use 1 divided by the determinant of A. So here's step A right here, and then you put that under here. So this is S3. Okay, and then S4, you have to multiply this number and this number. So step 4 is when you take and multiply this times this and then this times this. We'll go ahead and do that in our examples. Next card. So when you find the determinant, you're just going to take the front diagonal, the back diagonal, and then subtract. So this is going to be equal to 4 times 3 minus, okay, now pay attention to this one, okay, -1 times -2, okay? So what happens when you have two negatives becomes a positive. So this is equal to 12 minus 2, okay? Got the 12 minus 2. So this is equal to 10, okay? So here's your answer. Right here, I have 8 times -2 minus -4 times 4. And this didn't turn out the way I wanted it to. Looks like, oh yeah, it did. So I got -16, okay? And then with these two negatives, this is a positive, so this is plus 16. Okay, 4 times 4. Negative, positive, this is equal to 0. Okay? And then right here, same thing, front diagonal. So I have 12 times 32 minus -26 times -15. Okay? So this is going to be 384. Okay? These two negatives are plus, so it's going to be plus 26 times -15. So this is going to be 384 plus a -390. Okay? So this determinant is going to be -6. Okay? So finding the determinant is really kind of easy. The inverse is where it's going to take some work. So find the inverse. Step 1 is you have your matrix. Let's call this A. Okay. So we want to first find our determinant of A. So let's do that first. The determinant of A is equal to -14 minus 15. So this is equal to -29. Okay. Then we want to find the opposite matrix of A. So let's say op A. So this is going to be equal to, remember, flip your front diagonal. So this is going to be 7, -2, and then put negatives in front of the back diagonal. So -3, -5. Okay. So this is 2A, 2B. Flip your main diagonal and find the opposite of the positive, of the back diagonal. Okay, and then you have to perform scalar multiplication. So step 3 is so 1 over -29 times 7, -3, -5, -2. Okay, so this is going to be equal to, prepare yourself, 7 over -29. Negative and a negative is a positive, so this is going to be 3 over 29. Negative is a positive, so this is 5 over 29. And let's go ahead and clean that up a little bit. And negative is a positive, so this is 2 over 29. Okay? So if I were to multiply this by this and this times this, then we would get our inverse matrix, or we'd see that it's true. But this right here is an inverse matrix, okay? Likewise, let's do it again. So the determinant of A is equal to 54 minus 36. So this is equal to 18, okay? Op A, so the first step, switch your front diagonals. So this is 9, 4, and then put negatives in front of these numbers. So -6, -6, okay? And then we want to do the scalar multiplication. So this is going to be 1 over 18, okay, divided by, times 9, -6, -6, and 4, okay? So this is equal to 9 over 2 because in case you're not seeing it, 9 times 1 over 18 is 9 over 18, okay? In case you're not seeing it, -6 times 1 over 18 is -6 over 18, okay? So that's where these numbers are coming from. So here's my matrix. 1/2, -1/3, -1/3, and 4 over 18, if I wanted to do a decimal or anything, but this would be 4 over 18, and once you reduce, that's going to be 2 over 9. So this is 2 over 9. Okay? So here is your inverse matrix. Okay? One last example. So right here, we want to find our determinant. Find our determinant of A. So this is going to be -6 minus a -6. Okay, so this is equal to -6 plus 6, which is equal to 0. Okay, and we stop. Okay, and we cannot do that because 1 over 0 of 3, 3, -2, and -2, this right here is not possible. You cannot divide by 0. So that's not possible. Okay? So anyway, you have a unit test coming up. Okay? Let's see. You'll probably have maybe another quiz. I don't know. Let's not forget Quizlet. Quizlet.com app. And anyway, let's go ahead, make the most out of this. See ya!